marking the sums that we are busy with. We are busy timing and dividing with powers. So the moment you see the sum, all that we ever say is simplify. What is there to simplify? What is this about? You're busy taking powers and multiplying and dividing them. Because you've got to realize by looking at the sum, that's what I'm busy with. Multiplying and dividing powers. What's the rule? If the bases are the same, oh, there goes the sum. Nothing is the same. If the bases are the same and you divide, you subtract exponents. If you time, you add exponents. But you need to get those bases the same. So first step is you make the 10 into prime factors, 2 times 5. Now, if we save a little bit of time, we can already go and say, ma'am, I'm going to change that 10 into 2 times 5 over there. The 25 into 5 squared. 5 is done. 50.
5 squared times 2.
Okay. 2 times 5 squared, 5 squared times 2 doesn't matter. Alright? Calculator gives you the factors of that. Then we have to time in those exponents. That's the rule now. So we've got x times with 1 and x times with 1. So we've got 2 to the power x, 5 to the x, 5 to the x, 2 plus 2. Excellent. Guys that make mistakes usually say 2x plus still 1. Everything must be multiplied in. Then we've got 5 to the x here and 2 to the
X minus 1.
x minus 1 because it's 1 times with x minus 1. And the 2 is timed with x minus 1, so it's 2x minus 2. For that whole step, how many marks? 1. Maybe just 1, because all I've done is done the prime numbers, which isn't worth a mark, time it all in. Most of the time, if it's such a lot, maybe 2 marks, but it's something that is worth a mark that you are timing out the exponents. Maybe 1, maybe 2. Now the bases are not all the same, so the ones that are the same go together. So we make a big fat 2 and a big fat 5. For the 2, we have to the power x
Plus
minus x plus 1. Right. For the 5, we have to the power x plus 2x. Plus 2. There's no term if there's no sign. Minus x. Oh, couldn't I have just done this?
Yes, you could have.
Yes. And if you did, then these two wouldn't have been there and you get to the same answer anyway. Alternative? Okay, but now we're adding all of them. So this one must be minus and this? Negative 2 plus 2. Excellent, guys. So 2 is to the exponent of. Now, you know what I think about these textbooks, always just throwing away the x's, making them disappear. X minus x is again gone. You see it? Adding the like terms. And so the exponent is just 1, which I don't even have to write. If you want to write it, no problem. And then 5 to the power. Remember? You don't need a dot there because it was still multiplications, but you need a dot here. Otherwise it's 25. Are you with me? Right, methods of writing. So we have 2x falls away, x falls away. We've got 2 plus 2 is? 4. So we have 2 times. What is 5 to the power 4?
625.
625 times 2?
1250.
Is that okay? Do I have to show them this is 625? Show them how to... That's not what the sum is about. It's about getting prime numbers, doing the rule for exponents multiplied, exponents added and subtracted would be the next 1 or 2 marks, and then simplification should be 1 mark. Because it's just adding the like terms and getting to an answer. Number B, are you seeing your mistakes that you made? Alright, and correcting them. Right, then we've got 6 is equal to
2 times
2 times 3. 10 is equal to 2 times 5. 4 is equal to
2 squared.
And 15?
3 times 5.
Remember, it was multiplication. If I don't want to write it there, it's fine. If I don't want to write the dot, it's fine. I'm just going to start adding stuff. So then we're doing the method of exponent timed into this inside. So it's going to be 2 to the exponent of n plus 2, 3 to the exponent of n plus 2, because remember they both have an exponent of 1, and 1 times n plus 2 stays n plus 2. This will be then 2 to the power of n minus 2, and 5 to the power of n minus 2. Do you see me not writing anything then? It's okay. Dots if you like, multiplication if you like. Bottom is 2 to the power 2n, 3 to the n minus 2, 5 to the n minus 2. Is there something that can just cancel out? Yes, there is. If you didn't do that, is it okay? Yes. So put them all together and add, you should get to the same answer as me. So we have lots of 2's and 3's, and I would have had 5 if I didn't cancel it out. So now we've got 2 to the exponent of, read it to me, n plus 2 plus n minus 2 minus 2n, which is it. 3 to the exponent of
n
plus 2
minus n plus 2.
done. And then we've got an answer of the like terms that we are adding. N plus n is 2n minus 2n. Big surprise is 0. 2 minus 2. Okay, so it's just 2. To the exponent of 0, which is 1. Careful. And then it'll be 3 to the power of 4. So this is 1 times 81 is 81. And if you wanted to skip that step, it's fine. Okay. So, prime numbers, timing in, adding and subtracting exponents, answer. 4 or 5 marks for a sum like this. See, it's always the same recipe. Once you establish that I'm busy with multiplying and division, because now just after this we're going to be doing adding and subtracting. There's a different rule, because there are no laws for plussing and minusing. There's laws for multiplying and division. So again, the 6 will become 2 times 3. The 9 will become 3 squared. The 2, I'm happy with. It's just 2a. Did I write it down correctly? 27 is 3 to the power 3, and then that's 2 again, so no problem. So we're timing in the exponent law of if there's brackets in between. We are multiplying the exponent. So it's going to be 2 to the x, 3 to the x, 3 to the
2x plus 2.
Excellent. And 2, well, if I want to just write there 1 so that it's all the same. Don't have to. And then we got 3 to the
3x plus 3.
3x plus 3. And 2, nothing happened over there. I've established that there's big fat 2, big fat 3. Multiplied with exponents added. So this will be x plus 1 minus x plus 1. Agreed? Step by step, don't rush into it, because it's lots of marks, lots of work for a little bit of marks. For the 3, it's to the exponent of x plus 2x plus 2 minus 3x minus 3. Happy with that? Careful. Everyone at the bottom changes. There's 2 rules that you could apply, getting the same answer. The one is when I divide, I subtract exponents, or if I take this thing to the top, it'll become negative and negative because of that rule that if it's a negative exponent and you take it to the other side, the exponent changes. Be careful that you don't change the negative here. It's only the exponent. If it changes position from numerator to denominator, no problem. No problem. Numerator to denominator, but the exponent changes the sign. Then we're adding and getting 2 to the power of 2 and 3 to the power of negative 1. Do you see all of these changing? Please, in an exam or a test, if I give you one and the answer is plus x there, then that's it. So be it. And you can't do anything else then. Well, I would have written 4, but it's not a major simplification doing that. But the next one would be if you say 4 times 1 over 3. Remember why? Because it's actually over a 1 that you don't see. And then to make the negative exponent positive, you change the position from the numerator to the denominator. And your answer is 4 over 3, which can be written in various ways, but please leave it in improper fraction. If you go to calculator, it will always leave it in improper fraction. It doesn't say 1 1/3, it doesn't say 1, recurring, it says 4/3. Just leave it the way. The calculator kind of like helps you to do it the best way. Leaving an improper fraction is a good way of leaving it. Now that we've done the powers that we are multiplying and dividing, there's rules. But for exponents, with pluses and minuses, there's no rule. There's no rule that says if I've got 3 to the x plus 3 to the 4x, what's the answer going to be? And by the way, you can't simplify that. Okay. If there's a plus and a minus, there is no exponent law. So I'm saying there, for your toolbox, for your mathematic toolbox, this is what you need to remember. If you see pluses and minuses, you're going to have to factorize. Now factorizing, the only thing that you did in grade 10 for factorizing is, Ma'am said factorize, I factorize. There's a purpose for factorization, and the purpose is simplification. Once you factorize and break it up into smaller factors, there should be simplification, otherwise you're wasting your time. Just factorizing with no effect doesn't mean anything. You have to be able to cancel out. So when you factorize and nothing falls away because of cancelling out, division being possible, then you actually wasted your time. So now you did this, but maybe a little bit more easy in grade 10, where you saw that there was a minus in between them, and you know that you must factorize. Now this is the reason I gave you the types of factorization. In general, for a level 1 or 2 sum in a question paper, it's usually the common factor. Take out a common factor. So if I need to take out a common factor, I need to go back to my grade 9 factorization, which is not this difficult, okay? But a common factor to be taken out. So if I look at the top here, what do you think is the common factor?
3x.
3 to the power x, do you see it?
Yes, ma'am.
Well, what's going to be left if you take out 3 to the power x?
Only 3 to the power of 2 minus 1.
3 to the power 2. 3 to the power 2, because some people would like to say, take the 3 and the 2 out, so I suppose there's 1 to the 2 left there, which is completely wrong. You've got to realize what's left. By half of your teachers, or most of your teachers would have taught you, write them separately first, so that you can actually see what it means. Because remember, when you multiply, you add exponents. So when it's added, you can split them up again into multiplication. It works both ways. For a reason. I'm always going to ask you, why did you do this? So you say, ma'am, so I can better see. Okay, you've got a purpose. You don't just do stuff. Although what you're writing is not wrong, it might not have a purpose. So at the back there, I don't have to do anything. My purpose is I want to take out a common factor. Do you see the common factor better now?
Yes, ma'am.
And if I take out the common factor of 3 to the power of x, what is going to be left inside of the bracket? Now you can better see that it's 3 squared. So 3 squared, and I would even love it if you wrote 9. Are you with me? Sometime or other you're going to simplify this. And then at the back there, nothing.
Minus
A very important one. Because what does it mean? Timing out stuff will give you back this original sum. And if you factorize it, so do you see them moving both ways? Factorizing is that direction, and from there going back, there's products. But you have to still have the same answer. They can't be different from each other. So if I time this out, I'm going to have 3 to the power of x plus 2. And if I time this out with minus 1, it's going to be minus 1, 3 to the power of
X.
Okay. Which is then 9 minus 1, which is then 8. Do you see it happening here?
Yes, ma'am.
But what was the purpose of my factorization? I need them to cancel out to be able to simplify. So at the bottom, what do you think I'm going to do? Exactly the same thing. Also take out a common factor. So it's going to be 3 to the x, 3 to the 1, minus 3 to the x, times 3 to the 2. Remember what I'm doing. I am undoing. When I multiply, I add exponents. When I've added them, I put them back again because I want to better see what's left.
Yes, ma'am.
So if I do then take out a common factor of 3 to the power of x, What's going to be left there at the bottom?
3 minus 3 to the power of 2.
3 to the 1, which you can write, no problem. Minus 3 to the power of 2, which ma'am would love you to write as
9.
9, because you're going to simplify. There's still factors, exponents here, but are you going to use exponent laws here?
No.
No, it's just normal numbers. 9 minus 1, 3 minus 9. The main purpose was, why did I do factorization?
To cross
To be able to cancel out. Can I not cancel out here? Or even here looks better? And why not? Because of the pluses and minuses. Never ever in your life from grade, I don't know what, you were taught. You cannot cancel over a plus or a minus. You cannot cancel those, you cannot cancel those, or anything because of the plus and minus. That's why you factorize, so that the plus and minus is not there anymore. And when you cancel out, what's going to be left?
9 minus
9 minus 1. Do you have to show me 9 minus 1, or can you just say it? Can you show me 9 minus 1?
No.
You can if you want to, but I don't need to see it. And the same here. 3 minus 9, which is? Which gives me 1 is 4 over 3. Could you do this on the calculator from here? No, because of the x's. But over here, if you did go 3 to the 2 minus 1 at the top of the fraction, at the bottom 3 minus 2 squared at the bottom, it would give you the answer. So I don't even need to see that. Then you can say, but man, then I'm using my calculator, I'm happy. The sum says don't use a calculator for a reason, that you mustn't try and do funny stuff with actual numbers and just give me an answer, especially if there's no exits. Then you could actually do it with a calculator. But doing this on your calculator wasn't what the sum was about. This sum is about factorizing. Where would the marks go? You take out a common factor, no marks. No marks. Yeah. All I did was split them all up, and in grade 10 you did get a mark for that, to better see what's going on. But the factorizing could be, it's a little bit too much according to this sum for me, but it could be 3 marks at the top, 6 marks for one step, because it's all about the factorization. Usually it's 1, 2, 1, 2, and then for the answer, which would make it a 5-mark question. Are you with me? Not for the way you're writing it, you're helping yourself in doing that step, seeing better what's coming out of there. Alright, so types of factorization, common factor, that would be the level 1 and 2 sums, which in general is what they ask in the trick as well. But there can be others, and we're going to get to them, not today and maybe tomorrow also, but we're going to get to serious stuff. Because I have to show you that if they do ask you that for a level higher sum, then I have to have shown you that. So there's going to be rough stuff, like the grouping where you get a common bracket, difference of squares, quadratic trinomial, and the sum and difference of cubes. Can you imagine in exponents doing that? Well, you'll see them soon. Okay, so this one will do what? What do you
Take out
think?
an HCA. Oh!
It's
Yeah.
one fraction. Have you got an idea?
Get a common brackets.
A common bracket. There's only 2 terms. Okay, you're going to factorize, and therefore you're going to have a bracket that's the same. How?
Dot.
I don't know what that means. Okay? 2 to the? Is this the difference of squares?
No.
Is this?
Yes.
No. Okay, I'll show you sums when we get there that do look like that. But basically, this is just a normal common factor. You can take out a common, what? 2 to the x. Well, what's left then?
2 squared.
2 to the
X.
2 squared.
square's wrong, x is right. Because remember, it's still going to be the same sum. If you rewrite it, tell me if I'm right. Because when you time, you add the exponents. So if you said, if I take out 2 to the x and there's left 2 to the 2, what's this? 2 to the x plus 2. Because when you time, you add exponents. That's why it can't be plus 2. Okay? So we are having 2 to the x as a common factor, but it's not easy. Not easy on any level. So I've got to take out a common factor. And if you didn't realize it, you wouldn't get there. Now let's just leave the bottom for a half a second, because at the top now, I'm going to have left 2 to the x minus 1. Do you agree?
Yes,
If
ma'am.
I take out the 2 to the x, there's a 1 left. Don't forget about that 1.
Yes, ma'am.
And then the bottom, what do we do to the bottom?
Nothing.
Nothing.
Nothing. Why not?
There is no.
Except for that you're looking for factors and you're not finding them, but that you can actually factorize if you really wanted to. But what's the purpose? I want to cancel out. And I'm able to cancel out. So why
Yes.
go and fiddle with stuff that I'm already on my way? And I can cancel that out to get
The
an
whole
answer of
2x.
2 to the power of x. So explaining, because we're going to get there. 2 to the x minus 1, I could treat as a difference of squares, but there's got to be a reason, and for here, there's no reason. And the difference of squares always works this way. 2 to the what times 2 to the what gives me 2 to the 1x. How many x's will give me 1x?
None.
I say? I hear it? Half. Excellent. This is not clear cut. Half an x plus half an x is?
1x.
Who would want to do this? Nobody.
No one.
There's no reason. But there's going to be sums that go for this direction. We're getting there. And then, okay, the one was luckily just plus 1 and minus 1. Who would have thought that that is the difference of squares?
No one.
There's no reason why you would do it, but you could if it's necessary in another sum. Excellent. So what times what will give me 2 to the x? Those exponents have to be added to get to 1x. That's why it's half a x and half a x. Interesting. Just a little bit higher level. We're not getting sums like that for today. So on page 5, you've got homework 2e and f and 3c, which are going to be all about this factorization.